actually go on to this as well. So there's a lot of people moving through the departments. Also, there's a lot of people who are mothers and have kids, so they step away from the field and will come back later on. You know what I mean? So it gives us a lot of opportunities for those to happen. LIS is computer interfacing systems. Field engineer, like I said, these machines are very complicated, so changing up pieces of parts. It's easier to teach a medical laboratory scientist how to take apart and put together a machine than it is to teach an engineer all of medicine. Does that make sense? PhDs, they'll go back into either research or development, pathology assistants, professors, research, all sorts of stuff like that, toxicology. Some of them will actually go on to do business and actually produce analyzers and stuff like that, or software to try and help the medical field. I have several colleagues that did that. And over the next 8 years, 11% increase just due to the number of people that are going to be aging. You know what I mean? We're having an aging population. My parents, there's a huge swath of the American population that is there. And this is Quinn's personal opinion. Technology and automation and legislation are the variables to that. So, in my lifetime as being a medical laboratory scientist, we've seen medical reimbursements drop by 33%. So that could be a negative. However, technology though, how many of you guys have supercomputers in your pockets, right? A lot of us do, right? Or you will in the future. Technology and automation, there might be a future in one day, I had a director come to me and said, "You're really good at this. Would you be willing to analyze satellite facilities?" So I would get onto a computer. There could be a day where we won't have to work day shift. Maybe India will do our laboratory testing and analysis while I'm asleep, and I'll do theirs while I'm awake. And we'll be able to, analyze the data. There's lots of variables, and this field is changing very, very rapidly, and technology and all that stuff. Okay. What? I saved this. I changed it. That sucks. I'll fix it again. Okay, this was supposed to say case study, so let's forgive me for my misspelling. So let's give a little case study about how this actually affects people. Okay, so this little one was born when she was born with a it's called pulmonary atresia, and you guys just did the heart one. So the pulmonary artery, where that goes towards right here, this valve right there was stenosed. It was closed off. And so she had to have blood poke into the right ventricle and then bypass it into the pulmonary arteries, okay? So she had to have open heart surgery to do that. She also had a VSD, which means that the lower ventricles, the good blood and the bad blood, was mixing. So luckily, her ductus arteriosus, which is a bypass when you're in the mother's womb, was oriented, genetic defect oriented to the other direction, which siphoned off some of that good blood and gave it to her brain so that she didn't go hypoxic. So she had that. She also ended up having her lipids leaking into her lungs, her larynx collapsed. And so she had to go back up to the hospital to have a replacement, her third open heart surgery when she was 3. She ended up having hematoma in the thoracic cavity where they had to remove the blood, and they were worried about internal bleeding. And the lab helped run those blood tests. She got a blood transfusion when she was 5. She got a cell saver. They collected the blood from our surgery and gave it back to her when she was in this last one. But the good news, though, is with all the laboratory stuff that we do, she turned out okay. This is my daughter. So the things that we do actually have actual real-world impacts and stuff like that. I don't deal with a lot of patients, but I do deal with their specimens, and I know what those specimens are attached to. Every specimen has a name. Okay? And so that's what I do. Any questions, concerns, or insults? Okay. Thank you. Kind of fun?